morning, everybody. Thank you very much, firstly, for the invitation to come here from across the pond to talk to you about what is actually a very important subject, which is how you achieve healthier lifestyle and health benefits to the consumer whilst keeping the functionality and quality. And that's what I'm going to talk about today. I come from Leatherhead Food Research. For those of you who don't know us, I just want to very quickly introduce us. We're a small company based in Surrey, which is about 40 minutes from London. So if you're in London, please do look us up and come and visit us. We're very close to the station. It's not a problem at all. It'd be great to see you. We provide practical consultancy in ingredients, product development, sensory and consumer science, but also consultancy in regulatory and market insight. And my background, I'm head of microscopy, and it's got the micro word in it. I'm not a microbiologist, and I'm not a nutritionist, so what am I doing here? I'm a consumer. I'm a biochemist by training, but I fell into food science after I graduated, and I've spent all my life, working life, looking at food under a microscope, so that's what I do. And the image I have here is an image of a snack seen in the scanning electron microscope, and it's coloured so that the elements of sodium appear blue. So there's two very nice sodium salt crystals, sodium chloride crystals, sitting in this experiment snack. I'm going to talk a bit about the functionality and the quality issues around replacing sodium, and I'll probably call it salt, but it is sodium. It might be a chloride issue. We could perhaps debate that later. And I'm going to try not to put too many images in under the microscope, but it's very difficult for me not to do that. For me, this is an important topic, but more importantly, it's absolutely crucial to start knitting together the food safety, the nutritionists, and the food industry. And I think that that is a huge benefit from this workshop today. So what I want to do is to talk a little bit about functionality and quality. Some of the topics have been mentioned already, so I'll skip quickly through those. I can't see a clock, so perhaps you can give me a wave if I'm running. Then I'm going to talk a little bit about those aspects in key areas in products. And I'm going to talk a bit about some of the solutions, but it's all very much a skip through, if you like, a very broad outline. And I'm going to talk a bit about the consumer, because as a consumer and someone who takes a high blood pressure pill every day, and I like salt, and I like fat, and I like sugar, I'm afraid. I'm the naughty consumer, so I've got to think about the consumer. And then in summary, I want to think about how we might adjust food to make it enjoyable but also safe and healthy. So we talked this morning, the speakers have very eloquently outlined the salt reduction challenge and how you re-engineer foods to take sodium down and maintain delivery on so many different aspects is quite important. Absolutely key, primary, is food safety. So microbiological criteria is absolutely key. But once you take that out, and I'm going to take that out a bit, then the taste, the texture, the label, how many additives you might have is important. The shelf life stability is important for waste reduction. What we really want are foods that stay really fresh and then fail catastrophically over a period of about 2 minutes. And you don't want this gradual decline. The functionality and the quality, ease of manufacturing and cost. And functionality in use is very challenging because mainly we don't know what it does in a lot of products. We know some of them, and over the last 20 years or so, scientists have worked quite hard to understand the role of sodium in different foods, but we still don't really understand enough about it. So it contributes to flavour, not just salt, but flavour of other things. It controls the rise in dough, as we mentioned earlier. So it controls colour, it controls texture, it controls yield, which is important for cost. So I'm going to talk now a little bit about sodium in foods, in different foods. And I'm going to cover bakery, meat, cheese and snacks as typical examples. And I tend to see these in a different way to most people. And I want to share some of that thinking and that imagery with you today. I'm sure that following me are very experienced senior scientists who will come and talk a little bit about how they've managed to achieve sodium reduction or how the challenges have troubled them in this. So meat has been mentioned, and it's in terms of sodium as a preservative, it's very, very good. So I'm not going to comment and talk about that at all. It's very important. It's also very important for flavour, and as I said, not just salt flavour, but the taste, meaty taste, that juicy, meaty taste you get, the aroma you get. Obviously, if you take a steak before you cook it, you're going to season it. That's going to make a difference to what that steak tastes like. So if you're putting steaks to a consumer panel and you put them without salt, and we've had this debate with companies at Leatherhead where we're testing steaks and they want us to season them, and we say, are we going to weigh the amount of salt put on? Because you've got to put all these steaks to a panel equally, and they say, no, you just season it, chef. That's not scientific enough. So it's an issue as to how you actually do that. But it does enhance the flavours, and I think it's an area, and somebody asked the question earlier, it's an area where further research is needed to understand how simple salts affect other aromas and flavours. It affects the texture. And I've done some work in the past on the texture of meat and meat products and processes. It causes gelatinization, it causes the release of muscle proteins, it causes succulence because of that. So it gives you a more tender product. And as well as sodium chloride, there are other additives that are used in meat products for different reasons, which will contribute to the over sodium level. Sodium nitrite, sodium ascorbate, and phosphates. And there are issues with phosphates on their own without the sodium, and triphosphates. So that's something else to be considering. So this is the first of my structural images, and I want to take it to meat and consider what the structure of meat is. And if you have a leg of lamb or a leg of pork or something, and you have the muscles, I'm sure a lot of you are familiar with the structure of muscle. This would be the edge of a muscle cell, where these are the nuclei. They sit just under the membrane, and these are the fibrils that are inside that muscle cell. So it's a bit like a Russian doll in terms of structure. And if you go up in the electron microscope and look at one of these fibrils, you will see that there are actin and myosin filaments and various other proteins present within this structure. Salt and polyphosphate, so anything you do, the preparation of hams or sausages will affect that structure. And just as an example, if you look in the electron microscope at raw muscle, this is raw meat, you see the myofibril structure here. If you cook it, you'll see an instant difference in that you're solubilizing some of the proteins in cooking. You're also precipitating some of the proteins in cooking. And if you tumble that meat with sodium triphosphate and sodium chloride and make a ham, test ham, and then you look at it with the electron microscope, that's what you see. So they're all running this way with these myofibrils. So this is one here, another one here, and you're left with these bands. And there's quite a lot of debate in the literature as to how this mechanism works and what's going on. But essentially, you're solubilizing a lot of the muscle. My theory, which contrasts with offer in clinics, is that these are the overlap, these are the actin-myosin regions. whether that matters or not, if you want to replace the action of sodium chloride or sodium hypochlorite in a ham, you're going to have to do some sort of structural change like this in order to get the same texture. And moving on to bakery, I've got a couple of slides here just talking about the aspects of the functionality and then quality in bakery. It affects a lot, sodium chloride or sodium. It interacts with the gluten, protein in the dough, reduces the stickiness that way. It helps to control the yeast fermentation, so that if you have too much you get a slow rise, if you have too little you get too much. So even if you weren't manufacturing bread, but somebody at home was making bread, they would put the salt in. So that's an aspect that you've got to consider. The consumer will add salt to their food. And you have other sodium issues here. You've got bicarbonate, you've got emulsifiers and conditioners in bakery products. Moving on to cheese as an example, this has already been mentioned, it affects the texture. It will affect the texture hugely. It will contribute to the meltability, so if you're interested in pizza cheese, you don't want the cheese to remain as solid blocks that are unchanged by the pizza when you put it in the oven. You want it to melt. You want it to have good taste at the same time. It's also got additional additives. If you have a spreadable cheese or a processed cheese, you will have emulsifying salts which are often high in sodium, and they do affect that spreadability. When you buy a ton of cheese, spreadable cheese, processed cheese, the cheese has got to get into the tun. It's got to be processed in very large quantities and pumped through pipes into those pots. Then it's got to set just right. And all that is controlled by the sodium. And as an example of how cheese can change, I've got here some off-the-shelf cheese, cheddar cheese from the UK. This is the control. This is a thin slice through the cheese. It's been stained to show the protein at the top, the blue, and it's been stained to show the fat using fluorescent stain at the bottom. So these two are the control cheeses. You can see the protein nature with the fat in between. If you take the salt out, you make a reduced salt cheese, same process, same manufacturer. The protein is quite different, it's much denser. If you look at the fat is emulsified in control cheese, but it's tending to extend, whereas the reduced salt cheese is much finer emulsion. Moving on to snacks, salt or sodium chloride is used as a topical application in chips and other snacks for flavour. And it's also used in some of these extruded, expanded snacks as a functional ingredient because it affects the expansion of that snack, the bubble formation, and the crunchiness and the texture. And that's very important in terms of the consumer liking for a particular snack. This is a larger size image of that one on the first slide of a snack with two salt crystals sitting here and here. And these bubbles will be different if you take the salt out of this snack. This is the topical salt. If you have the salt is in the dough as well before it's fried, and that will make a difference to the size of the bubbles and the snackiness or crispiness of that potato matrix. And that's because it affects the starch. And if you look inside these snacks at the potato cells and the starch that's there, this is what you will see. Here's one potato cell, and it's got lots of swollen starch grains sitting in there, coloured blue. This is another one. Here's another one here. And you can see, I hope, that these ones, which are like donuts, distorted donuts in the cell, are much more easily visible than they are in this one, where they're completely swollen and lost their shape. And this is a bit dark, but actually they're much more intact than this one. So just sitting next to each other, you've got different starch swelling in a very small area within the snack. And that will make a difference as to how that then fries up and has a texture when you cook it. So those are the examples of the products I want to go through. I want to talk a bit now about some of the solutions, but as I say, really only in a very quick top level way. One of them is obviously to reduce salt by stealth, to take it out and not say anything, and slowly you will acclimatise your taste and liking for salt as a consumer. The other one is alternatives to sodium, using potassium chloride, and Michael mentioned that this morning. It's a bit bitter, so you would have to sort of balance sodium chloride, potassium chloride, or other forms of chloride. You can change the size and the shape, and I'll talk a bit about that, show you some images. You can change how it's distributed in a product, and some of you might have seen some of the research that's been carried out in the Netherlands in this area, and I shall show you an image of that. You can change the product microstructure, and this is an area that really could yield some big benefits. And you can understand the changes in the mouth, and I'm going to come back to that at the end. So, from research that was carried out a long time ago at Leatherhead, looking at different sizes of sodium chloride as a topical application, they found that if you reduce the size, and this in this graph, the red one is the smallest size, micronized salt, you get a stronger taste and hit of salt. If it's bigger, it's a little bit slower. It's all to do with how quickly it dissolves in your mouth. So what do they look like in the microscope? Well, this is a typical table salt just taken from a salt cellar. This little line here is 10 microns. So this is about, they range in size from about 0.1 of a millimetre up to 0.5 of a millimetre, quite large. This is micro salt, so very, very small. Each crystal is only about 1 to 2 microns. And this is a form of phosphate. I put this in partly because I think it's a really beautiful crystal structure, but this is a food ingredient that's added. But also it's got very interesting crystal shapes. It's got large surface area, flat and thin. So you could actually start to think about how that would dissolve in the mouth as a typical application. This image is an image of a fry, a French fry, that I took from my son's plate. He was 19 at the time, so you have to be quick at that age. And he just added salt to it, watching the TV the way they did. So our bad mother had a salt salad bun. But he did that, and I whipped a fry off his plate and put it in the microscope, and this is what it looks like. These are the surfaces of the potato cells, and these are a couple of the sodium chloride crystals. In here, this is 0.1 of a millimetre, so these are big. Just as an example, if you take much smaller salt, then that's what it looks like. And if this cluster were put at the same magnification as this, it would occupy approximately that little red square there. So, obviously you've got lots and lots of little crystals which could go over the surface. One of the problems is you can reduce the level of salt by having small salt, but you've got fat on the surface of chips and fries, so if they're too small, they sink into the lakes of fat and you don't taste them so quickly. Another way of changing it would be to change the density. So if they're having solid salt crystals, you have hollow ones, as you have here, and this is typical of something like soda low, let's say it's a 9. You can layer salt, and this is an example of layering salt in bread, where you have a layer of very low salt and then a layer of much higher salt. Overall, the bread has a salt reduction, and they found that you can do this and achieve the same sort of results with the panel as if you have a higher salt. So it's interesting that you have this contrast. You can restructure foods, and this was work done on lowering fat. In this image, everything that's white is fat, everything that's black is water, and it's an oil, it's a water in oil in water emulsion, or a WOW, and so you've got little water droplets inside, and that's to reduce the fat. But if you think about it, you can have water or low salt inside this water level and higher salt in this water level, and you can reduce the level overall but have it in that continuous phase that hits the mouth straight away. So you've got to think what's happening in the mouth. Very quickly, these two slides are just an example for you of a report that's available for you to download, carried out a few years ago now, looking at the evaluation of technologies. And these are the categories that they looked at. So there are quite a few relevant categories. Moving on now to the consumer, some research carried out on online, asking consumers about their eating habits and so forth. They asked them whether they were most concerned, Leatherhead asked them whether they were most concerned about salt, fat or sugar. And you can see most people are concerned with fat, but salt is quite low down in the middle. This is an interesting graph, same survey. What's important to you when you're buying and choosing food for different occasions. And the ones I want to pull out here are natural and fewer additives comes out highest. Sugar, salt and fat is pretty important, but more important if it's for everyday or home use. Not so important if it's for going out to a restaurant or a treat. In other words, people are prepared to have unhealthy foods as a treat. And when asked how much are you eating, too little salt, about right, or too much, most people think they're eating about right, the levels of salt. And that's an interesting one I want to leave with you, because why would they think that? I've got some thoughts in that area. Got 2 slides left, so that's it. Finally, in terms of structure, I want you to think about what happens in the mouth. When people put something in their mouth and chew it, and they get flavour, and they get salty flavour, and they get fat. And here's an example of those cheeses. This is the fat in the cheese, controlled cheese and reduced salt cheese I showed you earlier. And this is after they've been chewed for 5 seconds, spat out and then had a look at in the microscope. So everything you're seeing here that's bright is fat. And you can see that we change the fat quite differently as to whether there's salt there or not. So you've got to think about that's a consumer experience. So in conclusion, I've covered quite a lot very quickly today. Areas for further research. Well, I think obviously how does sodium affect the structure and the functionality and therefore the quality is an area that needs further research, but I would say that, wouldn't I? What else works in the same way? And is there another way to make the same product? I think it's really important to engage with the consumer in this area as well as the health and the industry. And then you've got to think what happens to the mouth in terms of structure, because that's what the consumer is experiencing. So I'm going to quickly finish there. Thank you very much for your time and for listening.